The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope you all are doing good, drinking a lot of water, taking care of your health, because the weather is at its peak. That is, it's very hot, so we will be losing water from our body, maybe through sweat also. So I want you to hydrate your body, drink a lot of water. You can have lemon juice, lot of citrus fruits also you must take, because you can see the COVID cases rising up. So take care of your health, children, because as we are going to complete our model exam, definitely we need to take extra precautions, because we have to appear our board exam. God is with us, trust in God, and also health is very important, because we know health is wealth. So take care of your health. Wish you good luck for every one of you, and do your best, give your best, children. Okay. So we have completed 2 chapters in our organic. So third chapter which we are going to see today is aldehyde, ketones and acids. First let us see what is an aldehyde. Aldehyde have a CHO group in their compound. Ketones have a CO group and acids have COOH, carboxylic acid. So now let us focus on the preparation of aldehydes and ketones. Now aldehydes and ketones together, they can be prepared by general methods. The first one is oxidation of alcohols, where we have learnt in the alcohol chapter, aldehyde on reduction gives primary alcohol, ketone on reduction gives secondary alcohol. So what is the reverse reaction of that? Primary alcohol on oxidation gives aldehyde, secondary alcohol on oxidation gives ketone. So this is my primary alcohol. Any oxidizing agent I can use, chromic acid, potassium permanganate, potassium dichromate, which will be giving me an aldehyde. Secondary alcohols on oxidation will give ketones. So the second step is dehydrogenation of alcohol. Dehydrogenation. So hydrogen is going to be removed. So here it takes place in the presence of copper at 573 Kelvin. You can even use silver. So primary alcohol, when it is treated with copper at 573, you get an aldehyde. Secondary alcohol at 573 Kelvin with copper, it gives a ketone. So always remember, primary alcohol will be for aldehyde and secondary alcohol will be for ketones. So these are the general reaction. Then now we are going to learn some name reactions. The first one is Rosenman reaction. In Rosenman reaction, we are going to take an acid chloride, which is RCOCl. An acid chloride, when it is treated with hydrogen in the presence of palladium and barium sulfate. Palladium is a catalyst and we use barium sulfate. It gives RCHO. Not only aliphatic, you can also prepare aromatic aldehydes, which is my benzaldehyde. So here I am going to take benzoyl chloride plus hydrogen in the presence of palladium and barium sulfate. It gives benzaldehyde with a byproduct HCl. The next one is a name reaction again, which we call it as an Ethard reaction. Ethard reaction, the starting reactant is toluene. Toluene is methyl benzene, which when treated with an oxidizing agent like chromyl chloride CrO2Cl2 in presence of CS2, this will be my intermediate which is formed. Benzene, H2 is removed. In the bracket you have O, Cr, again one of the OH and Cl2. This on hydrolysis, the whole complex will be removed and you get only CHO, which is my benzaldehyde. So benzaldehyde can be prepared using Rosenmund reaction, can be prepared using Ethard reaction, and you have one more reaction through which it can be prepared, that is nothing but Gattermann reaction. In Gattermann-Koch reaction, we have benzene which is treated with a reagent which is a mixture of carbon monoxide and HCl. So this carbon monoxide and HCl will activate the benzene ring. So this hydrogen will be CHO, will be replaced by CHO group, which is an aldehyde, and you use aluminium chloride as a catalyst. So this reaction we call it as Gattermann-Koch reaction. So in exam they may ask you to explain a name reaction, or they can give you the reactant, ask you to write the product and identify the reaction. The next reaction is the preparation of ketones alone. You cannot prepare an aldehyde, you can prepare a ketone, benzene with acid chloride, or you can take here aryl chloride, that is AR refers to aryl group. So it can be C6H5COCl, or R refers to methyl ethyl COCl, which on treatment with aluminium chloride as a catalyst you get this ketone. So these are the preparations, the main preparations of aldehyde and ketones. Now we will be moving into the chemical reactions of aldehydes and ketones. Yes children, now let us learn some of the chemical reactions of aldehydes and ketones. The first reaction is reduction to alcohols. So we know primary alcohol on oxidation is going to give an aldehyde. The same reaction we have learnt in the preparation of alcohol in the previous chapter. So aldehyde on reduction, with any reducing agent you use, you get your primary alcohol. Ketone on reduction will give your secondary alcohol. So this you can take any aldehyde and any ketone, that gives a corresponding primary and secondary alcohol, where CHO is replaced by CH2OH. Here CO is replaced by CHOH. So what happens? The next one is the preparation of hydrocarbons, that is aldehydes and ketones. They get reduced to hydrocarbons with two name reaction. The first one is Clemenson's reduction. Clemenson's reduction, aldehyde and ketones in the presence of zinc amalgam, that is zinc and mercury, in the presence of hydrochloric acid, mineral acid, you get your hydrocarbon. So here ethanol, that is acetaldehyde, is giving ethane, and this is propanol giving propane. So you can see CO getting reduced to CH2. So this is called as Clemenson's reduction. The next one is Wolff-Kishner's reduction. In both the reduction, we are going to get hydrocarbons as product. But in Clemenson's, the reagent that we use is different, that of Wolff-Kishner's reaction. In Wolff-Kishner reaction, we are going to use NH2, which is hydrazine. Hydrazine in the presence of KOH, potassium hydroxide, and ethylene glycol. So aldehyde is going to give my hydrocarbon. So this is another name reaction. The next one is what happens when aldehydes and ketones are oxidized. So oxidizing agent can be nitric acid, you can use potassium permanganate. Any oxidizing agent, aldehyde will give its corresponding acid. But what happens when you take a ketone, you get a mixture of acids having lesser or more number of carbon atoms in its product. So here if I am going to take this ketone, what happens? 1, 2, 3, 4, 5, 6. This is hexanon, hexane 3 on. This is going to give me a mixture of propanoic acid, acetic acid and butanoic acid. So that is how ketone gives when it getting oxidized to acids. The next two reactions are very important, frequently asked in our exam. Test for aldehydes and ketones. Just like to find out the primary, secondary and tertiary alcohol, if we have been given a compound, a carbonyl compound, how can I identify whether the given compound is an aldehyde or a ketone? So what are we going to do? For aldehyde or ketones, for both, what happens is tolerance test and Felling's test. In tolerance test, we are going to treat the given compound with ammoniacal silver nitrate. So, this is the complex of ammoniacal silver nitrate solution. This, when it is getting oxidized, you can see the CHO group getting oxidized to carboxylate ion, thereby giving a silver mirror. Either it will be a silver mirror or a black precipitate that is formed. So, that confirms the presence of aldehyde or ketone. The next one is Felling's test. In Felling's test, you can see the organic compound, that is a carbonyl compound, when treated with Felling solution A and Felling solution B. What are Felling A and B? A is aqueous copper sulfate and B is sodium potassium tartarate, which is also called as Rochelle salt. So, when these two solutions are mixed with the given carbonyl compound, what happens? It gets again oxidized to carboxylate ion and you get a reddish brown precipitate of Cu2O. So, if you get that precipitate, then the given compound must be an aldehyde or a ketone. So, these are the tests for aldehydes and ketones. Now, we have two more reactions to learn in this. With that is we have halophone reaction and aldol condensation. With that, the chemical reactions of our aldehydes and ketones are over. Then we will move to carboxylic acid. Next named reaction, that is in chemical reaction, is halophone reaction. That is aldehydes or ketones which has got a CH3CO or CH3CHOH group in their compound. When it is added with sodium hypohalite and sodium hydroxide, it gives a haloform which is CHX3. Now, where the CH3 gets converted to an haloform here. So, this is called as a haloform reaction and it is used to detect the presence of CH3CO or CH3CHOH group in the given compound. Now, how the reaction happens? Now, this is my propanone acetone. When it is treated with sodium hypohalite, that is iodide, it gives CH3COONA plus iodoform. This iodoform gives an yellow precipitate. So, that confirms the presence of a CO group in this compound. So, this reaction we call it as haloform reaction. The next one is Cannizzaro reaction. These are my carbonyl compounds which do not have an alpha hydrogen. When aldehydes do not have an alpha hydrogen, those compounds will be undergoing a reaction with concentrated potassium hydroxide to form an alcohol and a salt of an acid. That is, 2-formaldehyde will give methanol and here you can see HCOOK, that is sodium salt of formic acid, potassium salt of formic acid. The next one is benzaldehyde, do not contain alpha hydrogen. Again, when treated with concentrated potassium hydroxide, gives benzyl alcohol and sodium salt of benzoic acid. So, these are the reactions of Cannizzaro reaction. The next one is very important, which we call it as aldol condensation. See, we have learned that condensation reaction mainly it loses some water molecules like small molecules of water, that is condensation, removal of water molecules. So, here 2 molecules of acetaldehyde, when it treated with dilute NaOH, you get CH3CH, dilute sodium hydroxide, so you get an OH group added here. That is, when I have 2 molecules of acetaldehyde, CH3CH, one of the hydrogen from here goes and combines with oxygen, forms CH3CHOH and the remaining will be CH2CHO, which when heated loses a water molecule. How? One hydrogen from here has been lost. So, when these are lost, it creates a double bond here. So, it becomes butyl-enal. Butyl-ene is for double bond and al is for aldehyde. Same way, when I am going to take a ketone with barium hydroxide, I get CH3C. So, here one of the methyl group comes, O becomes OH and then one more ketone is there which becomes CH2COCH3. Again on heating what happens? One hydrogen from here, one OH from here, so creates a double bond and it forms a 4-methyl pent, 1, 2, 3, 4, 5 pent. Third carbon is having a double bond ene and second carbon has got a ketone group. So 2 on. So this is how aldol condensation takes place. Now we will go into carboxylic acid, learn about its acidic character, preparation and properties. The next one is preparation of carboxylic acid. We have learnt about carboxylic acid right from 10th standard. COOH group added, we call it as oic acid, and we also learnt about acetic acid, that is vinegar, how it is used as a preservative or preparation of acetic acid, if you remember children, right. So, some of the preparations in that we have 2 important preparations. The first one is from alcohols and aldehydes. Primary alcohols and aldehydes, when it is oxidized with alkaline potassium permanganate or chromic acid or any oxidizing agent, it gives a corresponding acid. Say acetaldehyde giving acetic acid, or even if it is ethanol, it gives acetic acid. Let us CH3, CH2OH. So, what happens here? CH3, CH2, CH2OH. You know, one more carbon gets added actually when you are getting a conversion of a primary alcohol into its acid form. Now, alkyl benzene is like methyl benzene, that is toluene, which when treated with a combination of potassium permanganate and KOH, you get the potassium salt of its benzoic acid, which again on hydrolysis the K gets removed and you get your H replaced, which is my benzoic acid. The next one is chemical reactions which are more important. The first one is a reaction with ammonia. Acid, when it is treated with ammonia, you get the CH3COO minus NH4 plus. This hydrogen combines and you get NH4 plus, which on heating loses a water molecule. That is 2 hydrogen from NH4 and 1 oxygen comes out. So, it becomes CH3CONH2. So, acid when treated with ammonia gives an amide. Now, this is a rare example where you have phthalic acid. Both the positions occupied by carboxylic acid, which when treated with ammonia, you get at both the hydrogen replaced by NH4 plus, which on heating gives phthalimide, that is CONH2, just like this form, which again on strong heating removes ammonia and you get your phthalimide, that is benzene CONH CO. That bond will be formed here with the removal of ammonia. So, this is a very important reaction for the acid, because they may ask you what happens or how phthalimide is formed from phthalic acid. So, you should be knowing the steps involved in those reactions. Now, we have cold electrolysis, halogenation, HBZ reaction, and then we will learn about the acidic character of carboxylic acid. We have come to the last part of our topic. In cold electrolysis, that is when an acid is treated with the sodium salt of an acid, when it is hydrolyzed in the presence of electricity, that is when it undergoes electrolysis, you get an alkane which has got twice the number of carbon atoms of the alkyl group present in the acid, with KOH, H2 and CO2 as your byproducts. Such electrolysis we call it as cold electrolysis. Next one is halogenation, where we are going to add a halogen atom to the acid. Now, there is not replacement, it is an addition reaction actually, but along with the hydrogen is also being removed. So, it is an addition come a replacing of hydrogen. So, what happens here? The second carbon, there is a presence of a halogen atom. So, this forms a alpha halo acid, carboxylic acid, which is alpha chloropropanoic acid. So, this takes place in the presence of red phosphorus and water. This is also called as HVZ reaction, Hell-Vollenhen-Zelensky reaction. Okay. The next one is electrophilic substitution, where you know electrophile comes and added to the benzene ring. But in the previous reactions when we were seeing, the group which was present in the benzene was ortho or para directing. But here this particular benzoic acid COOH is a meta directing group. So, it directs the incoming electrophile to its meta position, because there only the electron availability is more, and the ortho and the para position it becomes plus, that is electron deficient center, when COOH group is present. So when it is undergoing halogenation in presence of bromine and FeBr3, you get metabromobenzoic acid, and here in presence of concentrated nitric acid and concentrated sulfuric acid, the nitro group being an electrophile comes and added at the meta position, not at the ortho and para. Please remember this. The next one is, we will just do a comparative study about the acid strength of acid. Any carboxylic acid will undergo reaction with electropositive metals like sodium, or even with alkali like sodium hydroxide or sodium bicarbonate, or even it can undergo hydrolysis. What happens when it is treated with sodium electropositive metal? It tries to liberate hydrogen gas. When it is treated with sodium hydroxide, it gives out water. When it is treated with sodium bicarbonate, it gives out a brisk effervescence by releasing carbon dioxide gas. And when it undergoes electrolysis, it gives an anion and a cation, which is hydronium ion. Now to find out the acidity, there is a formula where pKa, the dissociation constant, will be equal to the negative logarithm of Ka. So when there is an increase in the Ka value, the pKa value decreases and stronger will be the acid. This carboxylic acid is actually weaker than our mineral acid like HCl and H2SO4, but it is stronger than phenols and alcohols. Because of this resonance structure, the stable resonance structure that it forms, you can see there is a shift of a double bond and a negative charge, because when two or more structures can be drawn, those are called as resonance, and it is stable than our phenoxide ion. So it is stronger than phenol. When an electron withdrawing group is present in an acid compound, the acidity actually increases because it stabilizes the carboxylate ion. But when an electron donating group is present, it decreases the acidity of the acid because it destabilizes the carboxylate ion. So I write benzoic acid being greater than formic acid, which is again greater than our acetic acid. So with this, the acid aldehyde ketone chapter is over. If you have any doubt, please call me. Take care children. Have a great day. Bye.